I received this nice Gilbert mantel clock today. It has a lot of nice features on it. Beautiful Victorian design on this case. Very detailed lion heads on the ends. Gold pinstriping on the bottom. All original hardware on this case. The reddish paint on the pillars has age cracks on them. Finish looks to be original. Some of the black paint and gold pinstriping looks to have been restored at one time in the past. We'll get the movement out and see what's going on with it. This is the arbor that controls the rate of the movement. Owner says the key got stuck on the arbor. This caused the arbor to come loose from something inside. Oil has dried to a black plastic-like grease texture. It's had bushings installed at one time. The gold gilt is damaged around all the bushings that have been installed. Lots of exposed brass and scratches. Incorrect length of bushings were installed. Then a rough file was used to file them down. This brass pinion has a stress crack in it. Not completely through yet. Dried oil. More damaged gold gilt. This pivot still has some liquid oil in it. Someone scratched an R through the gold gilt on the count wheel. Dried oil. The Gilbert logo. William Gilbert Clock Company, Connecticut. I'll remove the bell so I can have a closer look at the back plate. Looks like a butcher has modified the crutch. It's not shaped the right way. Damaged gold gilt. More dried oil. RC 10, 1986 has been heavily scratched on the back plate. Gold gilt is damaged. Raw brass is now exposed. I'll get the regulator assembly off for a closer look at what the customer was complaining about. The end of the arbor where it mounts to the circular worm gear is tapered. Nothing but the two splines holding it to the brass. No wonder it pulled away. It fits in here just like this. Rotating it, it moves the rack up and down to adjust the pendulum up and down. This holding support is locked in the mount by this small piece of brass that has been bent out. It's an interference stop tab. The suspension spring is distorted quite sadly. I'll deal with it later. Squeeze the lock tab a little and it'll slide through. It needs to be removed so the repair to the shaft can be done. Drive the arbor home in the brass worm gear and get it seated nice and snug. It's fairly flush. This anvil I'm using, it's hardened steel. It's harder than the steel arbor. I'll use this soft steel plug with a hole drilled in it to support the end of the steel arbor, so it doesn't get damaged. Round the steel arbor over. A hardened steel ball works good because it's short and leaves a nice polished finish. Looks good. Do a test fit before the movement is cleaned. The worm gear is meshing with the rack perfectly. A nice interference fit. Won't be slipping off now. Pivot holes inside the back plate are just as dirty. Gold gilt damage here and there as well. From what I see, the pivots look great. Arbor on the verge has been butchered. This blackish bluish colors show it's been overheated. This end needs to be fixed. Pivots are in exceptional shape. Lots of dried oil here as well. Well, I've cleaned the movement. The stress crack on this pinion isn't all the way through. It's locked in by the gear. Could have another 20 years of use left in it. It's not a high torque pinion, so I'll put it back into service. Now this suspension spring. I'll see what I can do to straighten it using a punch from a staking tool set. It's best to use a crosshatch direction to avoid creating a curled memory in the metal. It turned out good. Do a fit check. It's going to work out just fine. Someone really butchered this verge arbor. The end is smashed, probably from hammering on it. Tool marks from pliers. It's functional but badly butchered. Someone has replaced the crutch arm. Original may have been brass. I'm concerned about the crutch end. Configuration is completely wrong. This piece of soldered wire doesn't belong here. The crutch slot should be about 3/8 of an inch long to allow more freedom to the pendulum rod if the clock is tilted slightly forward or backwards. This bend here should have a tighter radius. Time to design a new end for it. I'll use this piece of mild steel to fabricate a new crutch end. This will give the area needed to taper. Need some clearance for the pendulum rod. These bending pliers come in several styles. This one has serrated jaws. Not the type needed for this job. I'll be using this pair that has smooth jaws. They won't leave any tool marks on the finished piece. The jaws also have different radiuses to create different bends. I'll use this area to do the bending of the crutch slot. Looking good so far. For strength, I'll use a scarf joint. Mark where the scarf joint is. Cut the crutch arm where the scarf joint ends. They match perfect. This is going to be a strong joint. Soft copper wire works good to hold the scarf joint snug while brazing it. Apply flux to the scarf joint. Flow brazing material in the joint. Hand work the excess brazing material there. Configuration of the new crutch is a big improvement over the old one. The scarf joint looks great. Everything is working as designed. Time to mount the movement in its case. I'll use these paper shims to level the case. The case needs to be leveled from side to side and from front to back before setting in beat. The long slot in the crutch allows for the clock to be slightly out of level from front to back. The pendulum rod should be centered in the crutch from front to back when the clock case is level. Then it's time to set the movement in beat. A piece of paper helps. Mark the center of the pendulum while it's at rest. Slowly move the pendulum from side to side. Pay attention to when each escape wheel tooth contacts the pallets while rotating. With the pendulum on the center line, slowly move the pendulum until the escape wheel ticks, and mark the paper. Repeat the opposite direction and mark the paper. Then double check. When the two lines of the tick and the talk are on the paper, and they intersect the center line with equal distances, the clock will have an equal beat, and is said to be in beat. If not in beat, on these American clocks, the beat is adjusted by slightly bending the crutch arm. For macro adjustments, bend up high on the crutch arm. This will affect the beat the greatest. For micro adjustments, bend down lower on the crutch arm. This will affect the beat the least. Adjusting the crutch arm doesn't affect the pendulum center line. Then repeat the marking of the beats on the paper. If there gets to be too many marks, a fresh piece of paper helps. The center line splits the two marks into equal halves now. Looks almost perfect. Now, as long as the case is leveled, the movement should stay in beat. This minute hand is loose. The hand has been bent to adjust for the looseness of the hand. The hand washer needs to be adjusted. I need to find a tool with a radius slightly tighter than the washer. This ball bearing looks about right. An anvil with a hole slightly smaller than the washer will give the best results. It only needs about 10/1000ths more of a cup to hold the hand snug. I'll give this a try. The hand is blued and has a grained finish to the material on both sides of it that I don't want to scar up. Instead of using metal tools on it, I'll use wooden tools because wood doesn't leave any unsightly tool marks. That's much better. Nice and snug now. A beautiful Victorian Gilbert mantel clock from the early 1900s.